Today, I will be presenting an article titled Structural Connections in the Brain in Relation to Gender Identity and Sexual Orientation. Before we begin, here are some terms and abbreviations that should be noted. FA is a measure of white matter connections that are consistent with sex differences. DTI is an MRI method which looks at white matter microstructures. GD stands for gender dysphoria. Cis means cisgendered. TRM is a transgender man. TRW is transgender women. HOM is homosexual men. HOW is homosexual women. HEM is heterosexual man. And HEW is heterosexual women. The first point we are going to go over is gender identity versus sexual orientation. Gender identity is a spectrum to show which gender a person identifies with, such as male, female, or non-binary. Sexual orientation refers to the gender that one is attracted to. Gender dysphoria is a symptom of those who identify as transgender, where they do not feel like they are at home in their own bodies. Transgender people have a higher likelihood of identifying as homosexual or bisexual compared to their cisgender counterparts. Both sexual orientation and gender identity is influenced by sex hormone exposure during the prenatal and early postnatal period. This leads to the brain becoming less sexually differentiated than cisgender heterosexuals. Previous studies mention that the link to gender dysphoria in the brain is a fronto-occipital parietal disconnection, but this does not account for homosexuality and bisexuality in transgender people. Because of this, white matter tracks are going to be observed through DTI and FA because there have been previous links to white matter and sexual differentiation, with FA values being larger in cisgender men than cisgender women. The experimental groups will be transgender men and women, homosexual men and women, and heterosexual men and women. It is thought that FA values will be far less differentiated in homosexual men and women, or possibly sex reversed. For transgender people, the FA values will correspond to their identified gender. Some of the research questions being asked from this study is, how does FA vary as a function of sexual orientation in only cisgender groups, and how does FA vary as a function of gender identity in all cis and transgender groups? To answer these questions, the following methods were performed. As for methodology, it is important to firstly note the subjects being tested. The transgender subjects were required to not have undergone any hormone treatment, have any previous chromosomal disorders, or have any mental disorders. Cisgender people had to have no gender dysphoria whatsoever and have no mental disorders as well. To determine sexual orientation, the participants were asked to rank themselves on the Kinsey scale, which I will go more in depth about in the next slide. What is important to note is that transgender men were asked to identify as homosexual if they were gynophilic and heterosexual if they were androphilic. Transgender women were asked to identify as homosexual if they were androphilic and heterosexual if they were gynophilic. To determine ICV volumes, magnetic resonance imaging was used, and 3D T1 weighted spoiled gradient echo pulse sequence images were acquired. Multi-slice diffusion weighted imaging was performed using an echo planar imaging sequence. For the diffusion sequences, a 32-channel phased array receiving coil was used. For the T1 sequence, an 8-channel coil was used because it provided better demarcations between white and gray matter in the occipital cortex for the purposes of the free surfer analysis used for calculation of ICVs. From there, volumetric segmentation was performed to derive total ICV measures for each participant, and ANOVA analysis were run to compare data within groups. This table highlights the age, sexual orientation, and total intracranial volume for each of the experimental and control groups. Sexual orientation was based on the Kinsey scale, which is a self-reported rank from 0 to 6, with 0 being completely heterosexual and 6 being completely homosexual. As seen on the table, transgender men and women have a much wider variety of sexual orientation rankings. The ICV values between transgender men and women followed their sex assigned at birth, with ICV values being highest in males and transgender women. ICV values did not significantly change based on sexual orientation. To measure FA value, diffuser tensor imaging was used. Then, a tensor model was fitted to the diffusion data, defining the eigenvalues of the tensor for each voxel to calculate individual FA maps. In order to visualize the FA values for each group, the normalized individual FA maps were averaged to create a group-wise mean FA white matter skeleton. The groups made were sex, sexual orientation, and gender identity. According to the figure on the right, Part A displays heterosexual men compared to heterosexual women and heterosexual men to homosexual women. Part B displays homosexual men compared to heterosexual women and homosexual men to homosexual women. And according to this figure, FA in sexual orientation was larger in cisgender men than cisgender women, with sexual orientation not being a confounding variable. As for the results of FA and gender identity, it was found that FA values were not significantly different in homosexual women, heterosexual women, and transgender women, which means that transgender women have sexually atypical brains. Transgender males had a lower FA than heterosexual men, but there wasn't any significant difference between transgender men and homosexual men. Transgender male FA values were also significantly different than cisgender female FA values. This graph highlights the points mentioned above, grouped into a singular image. The dark blue section represents heterosexual men, the light blue section represents homosexual men, the purple section represents transgender women, the yellow section represents transgender men, the orange section represents homosexual women, and the red section represents heterosexual women. From this data, FA means were significantly higher in men than women in the bilateral CST, forceps minor, bilateral SLF, right IFOF, and a trend in the GNU of the CC with the p-value being slightly over 0.05. There were no significant differences than expected for cisgender people who identified as heterosexual versus those who identified as homosexual. It should be noted, however, that homosexual women had notably higher FA values than heterosexual women, even though they were not significant. The main effect of gender identity was significant only for the bilateral IFOF and left ILF, whereas the main effect of sex was significant in the left CST, right SLF, light ILF, and subsignificant in the right CST. Overall, total intracranial volumes only differed by sex assigned at birth and were not significantly different in regard to the subject's current sexual orientation or gender identity. FA values were tested for the factors of sexual orientation and gender identity. FA values were not found to be different based on sexual orientation, but only by gender, with cisgender males having higher FA values than cisgender females. As for gender identity, FA values of transgender females were not significantly different than cisgender females, meaning that transgender females had FA values that correspond with their gender identity. Transgender males were different than heterosexual males and cisgender females, which means that their brains do have an overall difference than the sex they were assigned at birth and correlate most to those of homosexual men. In addition, the differences in FA values seen based on sex were mainly in the left CST and the right SLF, whereas the differences based on gender identity were seen elsewhere, such as the bilateral IFOF. The differences in FA values based on sex and gender identity overlapped in the left ILF. As you probably know, LGBT issues are prominent in today's society. Many people say that love is a choice, and who somebody identifies with is fully up to them. Those who are religious tend to disagree with the LGBT community to a great extent, which can cause mental health issues for many LGBT youths, as many other studies have highlighted. Thank you for listening to my presentation on white matter in the brain in relation to sexual orientation and gender identity.